Hello everyone and welcome back to the fourth tutorial of this video series where we are discussing how to use the MatPlotLib library as well as the NumPy and SymPy libraries to teach mathematics and physics. Okay, and so this is basically a continuation of the previous three tutorials that we've been discussing how to visualize and plot data, and in this specific tutorial we're going to start off by looking at scatter plots. So for our first example, I've decided to come online to visit the OpenAI ChatGPT, and this is one of the new innovations in computer science, and I just want to illustrate how this can be used as a tool for teaching. And to do that, I'm just going to generate either a piece of code or a sample set of data, and to do that I'm just going to open up a new tab here for trying out the ChatGPT, and then it takes me to a new conversation where I can initiate a greeting. So I'm just going to say hello and wait for it to respond. In the meanwhile, I can also just rename my chat, which I'm going to call program, and then I've given this some thought on what I want to ask the AI, and I wanted to generate Python code, but I don't want it to use the pandas library because I don't want to overcomplicate this tutorial, and I also have I don't have this installed on my computer, and I wanted to produce dummy data for simulating the correlation between time for breath held underwater versus lung capacity for a sample of 50 male adults. And if I hit enter, it'll start to generate this code. Alright, so just wait it out. Then we're going to take this code once it's completed, and that was really fast. It's basically doing all that on its own. Just going to copy that code, and then I'm going to take it over to my Jupyter notebook, and then by running that, it gives me two sets of data: lung capacity, which I can then refer to as lung underscore capacity, and I want to print that. Okay, and I also want to print the time underscore breath held. Okay, and so now I can start using this to simulate the data and visualize them in a scatter plot. So to draw a scatter plot of this data is actually quite easy. All you have to do is to import the NumPy and the MatPlotLib library. Okay, and so now we can start to just plot it using our available tools. So as before, we have to just instantiate a figure and then set the figure size. Then I call the plot method and I pass in the two lists. The first list is the lung capacity, and I'm plotting that versus the time breath held underwater. And I'm specifying the marker style as O or circles, little dots, and I'm also setting the line style to none, just so that no lines can appear. It looks more like a scatter plot in this case. Okay, because I'm kind of like simulating a scatter plot using the plot method. But the correct way of doing it is to actually use scatter method. So instead of saying dot plot, I'm just going to say plot dot scatter. And then the same parameters hold, except that this time around you don't have to actually specify the line style because scatter plots don't have lines in them. Okay, so I get the exact same result. Okay, so one extra thing that I might want to do is that I might want to set the radius size for each of these dots, and then inside of the scatter method we're going to specify the attribute s, which is the size of the dots, and we're going to associate with each dot a different radius value so that we get this more appealing picture over here to enhance the effect of a scatter plot. Okay, so that's just one attribute that may be manipulated. We can also do something similar with the colors. The colors are also chosen at random based on the sample size, which is 50. Okay, and then the attribute C is assigned to the value colors. So associated with each dot, a different color will be assigned, and so we're going to get this cayenne, green, purple, blue, yellow, orange, turquoise, all these different colors just to make our scatter plot look a little bit more alive. So obviously when it comes to graphs, you always want to make sure that your axes have labels. So we have here the same example, but I'm just assigning the string values lung capacity, and then I'm also just rendering a bit of LaTeX here inside that string just to show that X label is in liters, and then the Y label is the time of breath held underwater, which is measured in seconds. And so I'm going to get this graph over here, and obviously then also you want to make sure that your graph has a title. The title is self-explanatory. It just says graph representing time breath held underwater versus lung capacity, and then I also have a new line at the end of that string. It's going to give me that. It looks very beautiful. You can, once again, you can save your figures as before. Plot.save fig. Pass in the figure name, so graph underscore representing time breath held underwater versus lung capacity .jpg, And then if you render that, it should save it on your environment. So let's go and take a look. On opening this directory, tutorial 4, we have a new graph, which is the scatter plot. That's what's really nice about using the correct tools to do the job, is that you get really beautiful results. Okay, so obviously this data is just dummy data and there's really no correlation amongst the values. You can see that there should really be a sort of a trend here, but there's really none. So obviously you want to do a bit more in terms of emulating that correlation over there. You know, you might want to use some sorts of techniques to make sure that there is a correlation, that there is some sort of function which is the data values are obeying. But for the purposes of just illustrating how scatter plots work, it's really not necessary to go that much into detail right now. Not much more is going to be said. Here's another example. In this case, we're going to be emulating an experiment for photosynthesis versus the exposure to sunlight. I've just included another request for it to generate Python code to produce dummy data for simulating the correlation between exposure to sunlight and photosynthesis for a sample of 50 plants. And so once again, by running that, it will give me a piece of code that I can then copy and paste and include this in my Jupyter notebook, visualizing in the scatter plot using the MatPlotLib library. Okay, so this is quite interesting. You know, I can actually have ChatGPT do things for me if I'm, for example, if I'm not so familiar with using other data frameworks and stuff like that. This time it returned these two sets, sunlight, exposure, and I also want to print the photosynthesis. So here I have another two sets of data, sunlight exposure versus photosynthesis, which you can now use to visualize in a scatter plot, as we will illustrate. To plot this data is quite trivial. Just gonna use this piece of code. We instantiate a figure, and then we going to use the .scatter method, and then we pass in the two sets that we've just created, the photosynthesis versus sunlight underscore exposure, and I give it a marker style of O. And then I also want to change the size of the dots relative to the number of data values. So just make sure that the sample size is also provided. We've already declared that variable, so it's really not a big deal, but we also want the colors to vary depending on the number of values that we have. So I'm just going to set that attribute C equals to colors, which once again is the same as before. And then we have the X labels, which is exposure to sunlight. And then we have the Y labels, which is going to be photosynthesis. Okay, and then we have the title, which is a graph representing photosynthesis versus sunlight exposure. Upon running that, we get something similar. This time the correlation is a bit more obvious. I think ChatGPT had made a little bit more of an effort to find a relationship amongst these data values so as to correct a real world model to illustrate this relationship here. So that's pretty cool. We can also go and save that figure. So once again, plot.savefig, and then pass in the file name that you wanted to save as, graph representing photosynthesis versus sunlight exposure.svg. Okay, if we go back to our tutorial directory, we see we have a new SVG file over here. If I open that in the browser, it's going to give me this nice graph. I can zoom in on it, and it's a SVG file, so you can really embed it in any website. Really, it's really nice. It's got nice colors. So in the next section, we're going to look at how to construct bar graphs, and that's actually quite simple. So I'm just going to reset the kernel, and then we're going to import the appropriate libraries. So in this section, we're just going to look at bar graphs. So for that, let me just reset the kernel and import the appropriate MatPlotLib library, as well as the NumPy and SumPy library. And so for our first example, I have a really simple demonstration where we're just going to have three labels on the x-axis. That's going to be A, B, and C, together with the associated frequency values 1, 4, and 2 in that order. And then I'm going to instantiate the figure, and I'm also going to call the bar method and pass in the labels as well as the values to that parentheses. Okay, and so upon rendering that, I get this graph. Very simple but easy to understand. Okay, however, there is another way of doing the same thing, by first telling MatPlotLib library that we have a x-axis that needs three labels, and then we're gonna call on the bar method and tell and pass in the variable x. All right, and then also gonna specify the height for each of those labels to be 1, 4, and 2, but then we're going to change the ticks instead of providing the labels as an argument to the bar method, and so we're going to get the same result. However, I prefer the first method because it's much easier to understand in a sense. Okay, so then there are other attributes that we can manipulate. So for example, if I want the width of the bars to be narrower, I can specify the width to be equals to 0.1. Just going to give me that as a result. Alright, so you can play around with the parameters. And over here I have another example where instead we don't have a bar graph but a horizontal bar graph. The only difference is that little H over there to rotate the bar graph to be horizontal. Okay, so I'm going to get this as a result A, B, C on the y-axis with the frequency values on the x-axis. And what we can also do in this case is that we can invert the y-axis so that A appears at the top and C appears at the bottom by instantiating a subplot and then manipulating the axis by appending to it the bar h method. On top of that axis variable, I'm just going to call the invert underscore y-axis method with nothing in the parentheses. And it's just going to invert this axis here so that A appears at the top and C appears at the bottom. And in this specific case, if you would like to adjust the width of the bars, you're going to have to call the height instead of the width attribute inside of the bar h method. So I get the similar result A, B, C, but the bars are much narrower in this case. Okay, here's another example. So I'm going to take the linear space from 0 to 10 and divide that into 5, and then I'm going to generate 5 random numbers between the values of 1 and 10. I'm going to print that to the screen so that we can see our numbers in our list. I'm going to instantiate the figure, and then I'm going to call the bar method, and then I'm going to provide that with the lists x and h, that is our x-axis values, together with the frequency for each bar, and it's going to return this as a result. In this example over here, I have instantiated a figure, and I'm going to use the same variables as declared before, but this time I'm going to change the x-ticks to Coke, Fanta, Sprite, Pepsi, and cream soda, and I'm going to rotate those to 90 degrees so that they appear vertically like that. So that's pretty cool. There's something to keep in mind is that we always need to have the same number of elements in our labels list as we have on our x-axis to begin with. Okay, because say for example I had removed cream soda over here at the end of our list, we're just going to get an error because they have to be equanimous. There has to be the same number of elements in our set. So let me add that back. Cream soda. Okay, cool. Here's an example of a much larger data set where we take 50 numbers, we're dividing the values from 0 to 50 up into 50, and then we're also going to generate 50 values between the numbers from 1 to 10. We're going to instantiate the plot, and we're going to call the bar method and pass in those lists x and h, and we're going to get this. So in this section we're going to be looking at histograms, and for that let me just reset the kernel and import the appropriate MatPlotLib libraries and the NumPy library as well. Okay, and so for our first example, which is quite elementary, I just have a list X of values ranging from 0 to 100, and they may or may not contain recurring values. And then I'm going to specify the number of bins. So because of the way that histograms work, you want to take your x-axis and divide that up into intervals of the same length. What I'm going to do then is to instantiate the plot.hist method, pass in my list as well as my number of bins with inside the parentheses. And so I'm going to get this result, which is quite elegant. And so for our next example, we're going to make reliance on the Python random library and use the normal method to specify that we want a list of 250 values that are all centered around 170 with standard deviation of 10. I'm just going to print the list. So I'm going to get these values. This could be thought of as like measuring the height of a certain group of 250 students. To plot that is very easy. All we have to do is instantiate the figure and then call on the plot.hist method and pass in our list, and it automatically is going to give us this as a result. That's pretty cool. A similar way you can do that is just to take out the mean and the standard deviation outside of your random.normal method, alright, and then pass them in as variables. And then the same kind of principles allow us to draw this beautiful graph over here. Okay, so here I have a standard deviation of 170, and our standard deviation is 10, and our mean 170, so that's basically the average. Okay, and then we want to generate 1,000 values of that. So I'm not going to print the list because it's going to be way long and it's going to take up my whole screen. Depending on your needs, we can then start to change some of the attributes inside of the histogram method. And so the first one that I'm going to do is to just set density equals to true. And what that will do is it will just normalize this graph. In other words, it'll take each bar and divide it by the total number of data points, or data values, these bars become normalized. They will never grow any larger than 1 on the y-axis. Another attribute that I may be able to change in the histogram method is the attribute of cumulative, and that's just going to give me a cumulative frequency graph, which is basically a histogram, and it's going to climb like little steps all the way to the very top. Another attribute that you might want to set for your histogram is the hist type to step or bar. In this case, I'm just going to choose step to show you that it's just going to do a little outline of the histogram shape in blue, and that looks really cool. So that's a nice attribute to have. For our next example, I basically have a triple histogram where I have specified 3 lists, x1, x2, x3 of random values between 0 and 100. So sort of similar to our first example, and I put them all together into one list. So this is basically a list containing 3 lists. Okay, and I still want to specify my number of bins as 5. After that, it's pretty much the same. You instantiate the histogram method and I pass in the set x with the number of bins, and I'm going to get a triple histogram for each bin. And so a more intricate example of that can be made using the random number library again. And so here I'm generating 1,000 values within 3 different lists for my lists X. I'm instantiating the figure and I want 100 bins. And for each of those, I'm going to pass in a different color. So instead of having blue, orange, and green by default, I'm just going to have green, blue, and lime. Okay, and then I'm going to have my histogram method. I'm going to pass in the list X, the number of bins. I'm going to set the density equals to true, and then for color, I'm going to give it the list colors, which is defined over here. And then for labels, I'm just going to give it the colors. So it's automatically going to associate the right colors to the correct bars. And then I'm going to set the legend to the upper left. Okay, that's something we discussed in the second tutorial. Then I'm going to set the font size to 12, and that's it. That's all that's going to happen. Here's another example of a histogram. So let's explain what's happening here. That's 2 histograms that are separately placed on top of the same grid. And to do that, you just have to make sure that you place your 2 lists in the square braces within your histogram parentheses. So yeah, everything else is pretty much the same. I'm still using the mean and standard deviation method, generating 5,000 points, generating 2,000 points. Okay, and then this time my bins is contained as a linear space on the x-axis. Okay, so instead of having like specified 5 or whatever the case may be, it's choosing a range of values on the x-axis from -10 all the way to 10, and it's dividing that up into 30. And so yeah, that's pretty much it for this section. So in this section, we're going to look at pie charts. So let me just reset the kernel, import the appropriate libraries. And so the first example is quite elementary. We just have a set here x of values for the segments of the pie chart that obviously have to add up to 100%. So it's 35%, 25, 25, and 15%. I'm going to instantiate the plot figure, and then I'm just going to call the .py method and pass in that NumPy array x, and it's going to give us this beautiful plot. However, it's not really labeled. Nothing is clear from this graph. So to add some of the labels, we're just going to add a label list, and then we're going to also pass in the labels inside of the py method. Okay, so I'm just going to take my list x, pass that into the py method, as well as the labels, which is called fruits. So that I'm going to call them apples, bananas, cherries, and dates. So of course, once again, the number of elements in my fruits list have to correspond to the number of elements in my NumPy array list for my percentages. Okay, and so now it's going to just put the names all around the pie chart. But I can also change the starting position similar to that of the polar plots. I can say that the start angle should be at 90 degrees. Then it's just going to rotate the graph, the pie chart, by 90 degrees. Okay. But I can also separate the segments from each other, or at least one of the segments. I can also separate multiple segments from the pie chart by specifying a segment list and also passing that into the py method as a parameter, and then setting explode equals to that list. So for example, I've separated this second element in my NumPy array list and my fruit list from the rest of the segments in the circle. If I want, I can also put here 0.3. And it's going to separate the second and the third segments of my circle from this pie chart. If I were to separate all of them, I just have to keep going in this order. Now all of them are separated in a sense. They no longer glued together. They all have some space between them. And then I can also set the attribute shadow equals to true. So now each segment has a shadow around its border. Okay. I can still separate all the other segments from each other, and they all will have a shadow around them. So something like that. All of them have nice shadowy borders. I can change the color of my segments by specifying another list colors and then passing in as parameter colors equals to colors for my colors list. And I've chosen black, hot pink, blue, and then some other HTML hexadecimal value. And so it's going to give me this. I can also add a legend to my graph. So my legend, it's just going to be appended to the plot method. I'm going to instantiate that by calling plot.legend and then passing in the fruit list to my titles argument, and the location is going to be set to the upper right. So here I get a legend that's telling me what each of these segments are, although I already have them labeled. But if I want to label my graphs a bit differently, perhaps I want to put the label on top of the graph, then it may be a good idea to use the text method as we've discussed in the previous tutorials and set the position according to where each segment is located. So I'm just using the figure method by instantiating the figure. Then I'm calling figure.text method, and inside I'm specifying the X and Y position for my text. I'm calling it text 1, text 2, text 3, and text 4. You could call it the fruit labels. So for example, this could be apples, bananas, cherries, and dates. But for now, this is just illustrative purposes, so this should do just fine. So now the labels are no longer all around, but on top of each segment. So that concludes it for this tutorial, and we'll see you in the next one.